Okay, let's do this. This is homework number 3 for chapter 2. Yoshi graphed 2 lines. Here, I'll put this one in red. Y equals 2x plus 3 and y equals 2x minus 2. Oh, that was a guy. She got the graph at the right. Okay, those two right there. So which one's which? So is this the blue one and the red one? Or is it this the blue one and this the red one? So that's the problem. Okay. One of the lines to the right matches the equation y equals 2x plus 3, and the other one matches the line y equals 2x minus 2. Which line matches which? Okay. So really easy to tell. When you look at each line, and we've been practicing this, but the number at the end right here, that's where you start when you have x equals 0. So here's x equals 0. So here's the x-axis, and that's 0. Right? And that number right there, this says plus 3. So this point should be all the way up at 1, 2, 3. So this line right here is that graph. So this right here would be that line right there. So this would be y equals 2x plus 3. And then if you check this one out, this is minus 2, right? So on the x-axis, again, x-axis goes left and right. So you go to the 0, and then you find out where does the graph live, right? Which is, and then this says negative 2, which is right here, right? And this is the graph of y equals 2x minus 2. Okay. Yoshi wants to add a line y equals 2x plus 1 to her graph. Predict where it will lie and sketch a graph to show its position just by your prediction. Right? So for me, so you might need to write it down, but for me, I'm just talking. But if it's 2x plus 1, I predict it's going to show up at positive 1. So the predict's going to show up right here. And it's going to be the same graph, meaning the same slope as the other one. So it's going to be up 2 and over 1. Okay, so it's going to look like this. Okay, so that's going to be the line y equals 2x plus 1. Okay. Where would the line y equals negative 2x plus 1 lie? Again, justify your prediction and add the line, add the graph of this line. So I will do this in purple. So y equals negative 2x plus 1. That's going to start at negative 1. So it's going to start here. But since it's negative 2x for the slope, it's going to be going down 2 and over 1. So it's actually going to look like this. And that one's going to be y equals negative 2x plus 1. Okay. We write each of the following expressions in a simpler form. Your new expression should not contain negative. Okay, so this one, let's go. So we have what? So we're just talking about numbers. We got 5 and negative 3. So we got negative 15. Okay. Then we have x to the third and x to the negative 2, which means that it's going to go below and show up as a positive 2. So you can use your properties where you can just cancel these out. This means that there's 3 x's on top and 2 x's on the bottom. At the end of the day, so you work it out like how we did it with the expanded notation. It'll be 3 on top and 2 on the bottom. And if we work this out, we will get these, and our answer should just be negative 15x. Okay, that should be your answer. Okay, this one is 4p squared q, but there's 3 of those. So it's going to be this 4p squared q, and then there's going to be 3 of those. So that's 1, 2, 3. Okay, so, oops. So what do I have? I have 4 times 4 times 4, or I have 4 to the third power. P times P, or P squared, and P squared is P4, plus, and then 2 more times 2 more P is P6. So it'll be P to the 6th power. And the Q, there's 3 of them, so it'll be Q to the 3rd power. Okay, 3, 7, or 3m to the 7, and then m to the -1. So this is going to end up being 3m to the 7, and then that n, the m with a -1, it's in the, right now it's on the bottom. So right now it's like down here. Okay, but it's negative on the bottom, negative exponent on the bottom. So what that means is we're going to move it to the top and make it positive. So that's going to get moved to the top, which means on top up here, and it's going to be positive 1 now. Okay, so total. So that means that there's really 1 left at the bottom, which means we don't need to do anything down there. Okay, so my final answer, 3m8. Okay, and last one, I believe. Which graphs are below have a domain of all real numbers, which have a range of all real numbers? All right, so notice how this on A right here, see that arrow right there? You see this arrow right here? Okay, it's going to keep going. It's going to keep going down. And when it keeps going down, it's going to keep going in this direction. Okay, this one too. It's going to keep going up. And when it keeps going up, it's going to go in this direction. So the domain is going to be from all the way from the left to all the way from the right, or from negative infinity to positive infinity. Okay, which means that that one has a domain of all real numbers. So A, domain. Okay, we can call it x is between negative infinity and positive infinity, but we can also say it's all real numbers. Okay, and same thing right here, because it keeps going down, we're going to go ahead and say, because the further down it goes, it's going to keep going down. The further up it goes, it's going to keep going up. So the range is also all real numbers. So this one, the range is also negative infinity to x to positive infinity, or you can say this is all real numbers. Excuse me. Okay. Just look at the graph. Okay. So domain, range, they're both all real numbers. This one right here, you can see that has an arrow, which means it's going to keep going. When it keeps going, that means it's going to keep going in this direction. This has an arrow, which means it's going to keep going also. When there's an arrow, it's going to keep going. So the domain is from negative infinity x to positive infinity, or all real numbers. Oop. And the range on this one, oops, I forgot. Range should be y's. Okay. The range on this one, right? You see how the arrow? It's going to keep going. It keeps going in that direction. Right? It's going to keep going down. And this one is going to keep going down too. Right? But it doesn't keep going up. So because it keeps going down, it's going to go all the way down here. And because it keeps going down, it's going to go all the way down here. Okay, but it doesn't go all the way up. So the range is not all real numbers. The range only goes from negative infinity all the way up to this point right here, which looks like positive 6. So the range is from negative infinity, because it does go all the way down, and it's a y, but it does go all the way up to 6 only, and it does include 6. So this one doesn't have a range of all real numbers, right? So maybe we can cross that out or something. I don't know. I'm having a hard time understanding. They're just saying which graph, so we can say graph A so far only has all real numbers. Right? Graph A is the only one that has all real numbers for the domain and all real numbers for the range. Graph C, again, if you look at this, it has an arrow going this way, then which means it's going to keep going in that direction. And it has an arrow here, which means it's going to keep going in that direction. Okay, so it's going to keep going as far as we can see on the right hand side, but the left, it's going to stop right here at -2. So the domain, it's going to start at -2, less than or equal, because it does touch negative 2x, less than or equal to, or actually just less than y, or less than now infinity. Okay, so this one doesn't have all real numbers. So we can say, you know what, this one, the domain is not all real numbers. Okay, the range, let's see. See, because it keeps going up, slowly up, it's going to keep going up here. And because it's going to keep going this direction, slowly down, it's going to go all the way down as well. So this one, the range is all real numbers. Or we can say that this is going to be from negative infinity, y, to infinity, or all real numbers.